Let us look at example 14. 14 is another simultaneous equation. So before we start any simultaneous equation, it's a good idea to label the equations. Let me call them 1 and 2. This will make it convenient for us to write our working and explain what we are doing. So now in this case, one of them is in index form and the other is in logarithm form. For the one in logarithm form, is made up of two terms, but it has the same base of 2, so we can combine them using your quotient rule. It's a subtract, so we'll use the quotient law. Let's work with 1 first. 1, we have 2, 16, and 4. I think it might be a good idea to change them all to base 2. So 2p plus 2 equals to 2, 4, 2, 2, 3 over 2q. Okay, let me simplify the right-hand side. 2 to the 4. This will become 3q. Okay, use the indices law of am, this part, to the n is amn. All right. And then for the next line, we will be using the indices law of am times an is am plus n. So let me continue. This will be 2, 4 plus 3q. Maybe I can copy this down. Now, since both left and right hand side has the same base, I can just let the powers equate. Can also make p the subject. And I will call this 3 and leave it aside for use later. Let me now do equation 2. Log to the 2, 6, and log base 2, 15q minus 3p. Let's use the quotient law, log 2, and make a quotient 6 out of 15q minus 3p is 1. The base is 2, the power is 1. Base is 2, power is 1. We cross multiply. Okay. I'll call this 4. And we can equate the p's. 3 equals to 4. For equation 3, 2 plus 3q is 5q minus 1. So I'll bring this 3 to the other side, so 2q, and bring this 1 to here, 3. Okay. Then I can substitute into equation 3. P would be equals 2 plus 3q. Now get 6.5. So P is 6.5. Q is 1.5. There you go. You have your example 14.